Okay, now I want to talk about solving systems of inequalities. So we've been looking at systems of equations. Now we're going to plot solution sets for systems of inequalities. So it's pretty much the same thing, it's just now you're taking values greater than or equal to some linear equation. Okay, so the graph of a linear equality is a set of all points whose coordinates satisfy the inequality. So if you have something of the form y is greater than mx plus b, or y is greater than or equal to mx plus b, then you want to shade above the line. And if it's a less than, then you want to shade below the line. And then if it's strictly a greater than or strictly less than, then you want to use a dotted line. And if it's a greater than or equal to, you want to use a solid line. So hopefully that's review for you. Okay, so now the first example we're asked to solve for, or to plot 6x plus 3y is greater than or equal to 3. So the first thing we're going to do is we're going to solve for y by subtracting 6x from both sides. So you get 3y is greater than or equal to negative 6x plus 3, and then you divide both sides by 3, and you should get y is greater than or equal to negative 2x plus 1. Okay, well, and since this is a greater than or equal to, we're going to use a solid line. So this is, here's the y-intercept is plus 1, and then we're going to have a slope of negative 2. So I'm going to go down 2 and to the right 1, or up 2 and to the left 1. So there's my line. And I want to use a solid line because this is a greater than or equal to. And now I want to shade above and to the right. So that would be over here. Okay, so there's the line. Here, this is the set of all points. Y is greater than or equal to negative 2x plus 1. Okay, now in the next example we have a strict inequality. And I'm going to start by solving for y, so I'll subtract 2x over. And I'll be left with negative 6y is greater than or equal to negative 2x plus 12. I'm going to divide both sides by negative 6. And hopefully you're all screaming that you should change the direction of the inequality when you divide by a negative number or when you multiply by a negative number. So this should give me y is less than 1/3 x minus 2. Okay, that'd be one way to solve it. Another way to solve the same thing, so I'm just going to show you that this works either way, is that you could add 6x to, or 6y to both sides. So you'd have 2x is greater than 6y plus 12, and then you'd probably subtract 12 over, so you get 2x minus 12 is greater than 6y. So then when you divide both sides by 6, you get 1/3 x minus 2 is bigger than y. So either way, you should end up with this. Either you divide by a negative number and you remember to flip, or you add the negative number over to the other side and then you don't have to divide by a negative number anymore. Okay, in either case, that's the inequality. So we're going to plot that line, and we're going to plot it as a dotted line. So let me plug in some points. So we know that negative 2 is our y-intercept, and then we're going to have a slope of 1/3. So I'm going to go up 1 and to the right 3, and down 1 and to the left 3, and this should be a dotted line. Okay, and now I want to shade below that line. So it should be all these points strictly below that dotted line. Okay, so that's the set of solutions to these inequalities. Now I want to review how you would shade if you had a vertical line. Well, if you had a vertical line, that's something like x equals some number, right? And so if you want to shade to the less than some number, you would shade to the left. And if you wanted to shade greater than that number, you shade to the right. So let me just give you an example. If you wanted like x less than or equal to -2 or something, right? Then you would shade all these values over here. And if you wanted greater than or equal to something, like x is greater than 3, let's say, then maybe here's x equals 3. Well, we'd want a dotted line. And you would shade over here. If you have a horizontal line, then that's like y equals some number. So you're going to shade above or below. So horizontal lines are like y equals a number. And so if I had, let's say, y is less than or equal to -1, let's say, then you would take all these values below. So you're shading below. And if you wanted y is greater than 1, then that would be everything above, and I would have to have a dotted line at y equals 1. You'd shade everything above there. Okay, so the lines are pretty straightforward. Now if you have a parabola, like y equals x squared, then it's going to look something like that. And so if you want y greater than x squared, you shade inside the parabola. And if you want y less than x squared, you would shade below the parabola and outside. Okay, now finally, if you have a circle, that's something like x minus h squared plus y minus k squared equals r squared. Okay, well if you want to do less than, then that's going to be inside. So if you have the same thing, but you want like x minus h squared plus y minus k squared is less than r squared, then you're going to shade inside the circle. And if it's greater than r squared, you shade outside the circle. That'd be outside. So that's just a crash course on shading. So now let's look at this. It says the graph the inequality x squared plus y squared is less than or equal to 9. So that's a circle of radius 3. So I'm going to do my best to draw a circle of radius 3 here. And we want to be less than or equal to that, so we're going to shade inside. So let me get my purple pen here. Okay, so I shade all the points inside of there. Something like that. And I'm going to try that again. I must have pulled my pen off. Here we go. Okay, so that's the solution to this inequality there. Now here we have y is greater than x squared minus 4. So we want to draw a parabola with vertex -4, 0, -4, and we want to draw it as kind of a dotted line parabola. It's going to go through those points. Okay, and I'll shade it. I'll shade it with blue. So since we want greater than, we need to shade inside of this thing. Inside and above, I guess. So this is all y that is strictly greater than x squared minus 4. Okay, so that's all there is to it for this first page. Alright, now in example 3, we're going to do a system of linear inequalities. And so here you graph both lines and you shade both regions, and then the solution set's the part that's been shaded twice. So we have 6x plus 3y is greater than or equal to 3. And so I'm going to solve for y. So I get 3y is greater than or equal to negative 6x plus 3. And then that's y is greater than or equal to negative 2x plus 1. So there. Oh, this is the one that I shaded earlier actually. It's a line of slope negative 2 that goes through 0, 1. So I insert line. There we go. And we want to shade to the right of that line. So there's my first inequality. And now I'm going to, in red, I'm going to solve for the other one. So this is 2x minus 6y is greater than or equal to 12. So that was what? 2x minus 12 is greater than 6y. So y is greater than or equal to, let's see, 1/3 x minus 2. So y is less than 1/3 x minus 2. So that would be negative 2 for my y-intercept and a slope of 1/3. And this is a strict inequality, so I'm going to draw a dotted line through those points. And now I want to take all points less than that line, so let me insert, let me shade below there in pink. Okay. And now the point is that the solution set is everything that's been shaded twice. So it's the solution set would be all these points here, and then anything below the red line over here, basically. Okay? So that's your solution set. Okay, now we're going to do a system of inequalities where it's not just linear. So the first one here, let me kind of color code this. This equation, or inequality, is a circle of radius 4 with center 1, 1. So here is 1, 1, and I'm looking at a circle of radius 4. So 1, 2, 3, 4, 1, 2, 3, 4, 4, and 4. I'm going to do my best to draw a circle of radius 4 here. It's okay, it's not my best, but it'll do. Okay, and we want to shade inside of that circle. Okay, sorry, it's taking me a little while to shade, but so shaded in blue is everything where x minus 1 squared plus y minus 1 squared is less than or equal to 16. And then in red, you get that y is greater than negative x plus 1. So here's plus 1, and we're taking a slope of negative 1. So it should look something like that. And again, the solution says everything that is shaded to one side of that line and inside that circle. So we're looking for y greater than that, so we're going to shade above. So we'd shade everything up here. Okay? And of course the stuff that's actually a solution to the system will be the stuff inside the circle and shaded above. So the solution then would be, this stuff in here. The stuff that's been shaded twice. Okay, so now we have one last example. And so that's going to be a parabola and a line. So the parabola is y equals x squared minus 2. So x squared minus 2 would be something like this. So I'm just taking the equation of a regular parabola and shifting it down 2 units. And because it's a strict inequality, I'm drawing it as dashed lines. And we want y less than that, so we're going to shade below that. And then we're also going to shade below, so that's blue I kind of shaded there. And we're also going to shade below y is less than or equal to 3. Well, y is less than or equal to 3 would be right here. And of course we want it below the parabola, so I'm not going to draw that part. So y is equal to 3 here. So we're going to just shade below this thing. So the solution says it's going to be everything that's below the parabola and below that line. So it should be strictly below the parabola and then less than or equal to that line. Okay, and the bonus question is asked is it possible for a system of inequalities to have no solution? Can you draw an example? Yes, it's possible, and you could always do like a circle or 2 circles where you'd have like everything has to be bigger than 1 radius, but then the other one you'd want everything inside of that, and then there'd be no common intersection, so there'd be no solution. So an example of this would be like x squared plus y squared is less than or equal to 1, and then x squared plus y squared is greater than or equal to 4. Something like that. You could cook up a lot of different examples here. This is just one example.